So realizing that I just went off the screen a little bit before, I guess I wasn't watching myself writing on the computer. I noticed that you probably couldn't see the last couple lines here. So after I ended up that last question, knowing that this is a factor means that when I substitute in 2, it's got to be a root. So f of 2 equals 0. I can plug in 2 for x and just set it equal to 0, since 2 comma 0 has to be a point on that function if that's a factor. So I just plugged in 2 and I worked it out, and then you can substitute and solve for k. You get k equals 3 by the end. All right, the last two questions should go pretty well. Inverse proportions, if you remember, we said we could set them up as x1 times y1 is equal to x2 times y2. This is kind of like the fast SAT way to do it. Similar to regular direct proportions, except that would be x over y equals x over y. So since they're inverse proportions, it's the opposite of dividing, we're going to be multiplying. So now we just substitute in the two different values, right? He weighs 150 pounds. We can make that our x1 if he is 4 feet away. So we make that our y1. And then we look in the information, we get another weight, so that's 120 pounds, for how far away would that person have to be. So you multiply this out, you get 600 is equal to 120 times y, divide by the 120, and you'll find out that that person has to be 5 feet away. So the answer is 5 feet away from the fulcrum point. All right. And that brings us up to the last question, which is our graph. Right now, I noticed that somehow on the document, this point got floated way over. That coordinate was supposed to be given on the graph. That's our way of knowing what the x value and the y value are going to be. So we're going to need to use that later on in the problem. We just zoom back out of here. Okay, so find the equation of the graph. Well, if we look on the graph, we've got a couple important pieces of information. Right here, we've got a root, and right here, we've got a root. Now we can see it's going in opposite direction, so it's going to be an odd degree. It's going to have a negative leading coefficient because it's going down to the right instead of up to the right. Positive coefficients go up to the right, negative coefficients go down to the right. So this root also is interesting to note because we know that it bounces off. So therefore, this thing right here has to be a double root. Could be any even-powered root, but for the simplest possible case, we'll go with a double root. This one, however, is going to be a single root since it slices right through. So because x equals -1, we know the factor has to be x plus 1, and we know it's got to be a double root, so it's going to be squared. Since this one is x equals 0, we know that that's just going to be a factor of x, and it's a single root. So when we go back over to the beginning, we can start writing our equation. We know there's going to be a coefficient, some coefficient we're going to have to solve. That's going to come from using this coordinate. And we have an x plus 1 factor, but it's a double root because it bounces off, so it's squared, and then times an x. So that's the beginning of our equation. Now we're going to use these two values to substitute in. So the y is -8, and we have an a value, and the x value is 1, so 1 plus 1 squared times 1. -8 is equal to a times 2 squared times 1. So -8 is equal to 4a, 4 times 1 times a. So if we divide this over here, we get a is equal to -2. And that's kind of what we were expecting anyway, because with that negative leading coefficient, we knew it had to be going upside down. So our final equation is a value goes in front, -2, x plus 1 squared times x. And if you graph that out, you should see something similar to that on a similar window, and you can always check the table of values to make sure that that coordinate's on it. All right. Hope that helped. Good luck with your quiz on Friday, and look forward to seeing you guys in our Zoom sessions.